Let's do an example now where we get working with these exponential functions. So we're going to search for a formula for the exponential function, which passes through 2 points. And we have 2 examples here. In the first example, we have 0, 5 and 2, 20 are the points that this exponential function passes through. And in the second example, we have 1, 2 and 2, 4 thirds. So what we are looking for in part A is a function f of x, which is of the form a times b to the x. And we need the graph of this function to go through 0, 5 and 2, 20. And what that means is that f of 0 is going to have to be equal to 5, and f of 2 is going to have to be equal to 20. Now we'll go ahead and take our assumed form of the function, a times b to the x, and we'll go ahead and write what f of 0 is. For a function of this form, it's going to be a times b to the 0 power. And so 5 has to be equal to a times b to the 0 power. Now b to the 0 is 1. And so that means that a has to be equal to 5. And so we are halfway to our solution, because we know now that a is 5, so this has to be 5 times b to the x. Now, what about the second piece of information, that f of 2 is 20? Well, f of 2, if you take 2 and put that into a times b to the x, you get a, which we know to be 5 now, times b to the second power, because x is 2. And so we have that 5 times b squared is 20. And dividing both sides by 5, we get that b squared is 4. And so b would have to be plus or minus the square root of 4, or in other words, plus or minus 2. Now, we don't allow for negative bases, so we'll go ahead and take the plus here. But remember, in general, if you have something squared equals a number, then you're going to get 2 solutions. But we only have one, since we only allow b to be positive, and so our function, f of x, is going to be a, which is 5 times 2 to the x power. And you could go ahead and check your work by plugging in x equals 0 and 2, and you'll see, in fact, that this function goes through both of the points that are required. Now, in the second problem, we won't get so lucky, and what I mean by that is, in this first problem, because 0 was one of the points that our function went through, we were immediately able to determine a, because b to the 0 is always 1. But in this next problem, we won't be so lucky, but we can still do it. So let's go ahead and copy the points down so we don't have to go back and forth. 1, 2 and 2, 4 thirds. And we're looking for a function, f of x, which is of the form a times b to the x. Now, this first piece of information tells us that f of 1 needs to be equal to 2, and f of 1 is also equal to a times b to the first power. The second piece of information says that f of 2 is equal to 4 thirds, which, taking this x value of 2 and putting that into the assumed form of f of x, gives us that 4 thirds equals a times b to the second power. What this leaves us with is 2 equations and 2 unknowns. The first equation being a times b is 2, and the second equation being a times b squared is 4 thirds. What I'm going to do is I'm going to solve for a in the first equation and put that into the second equation. So from the first equation, we get, if we divide both sides by b, that a is 2 divided by b. Then I'll put this into the second equation here, and I get that 4 thirds is equal to 2 divided by b times b. And this b needs a square. So b squared divided by b is just b, so this is going to be 2 times b. In some problems, the arithmetic using, or not the arithmetic, but the algebra using properties of exponentials might be a little bit more challenging, but in this problem it turns out to be relatively straightforward. So we know that 2 times b is 4 thirds. Dividing both sides by 2, we get that b is 2 thirds. So we're halfway there. We know what b is. Now we can take this b, put it into either equation 1 or equation 2, and find a. So b is 2/3. So going back to what equation 1 says, it says that 2 is a times b. So 2 is equal to a times b, and b is 2/3, so 2 is a times 2/3. So I can multiply by 3 on both sides and divide by 2 on both sides to get rid of the 3 here and the 2 here, and I get that a is equal to 3/2 times 2. 2's cancel, and I get a is 3. So that means that my function, f of x, is 3 times 2/3 to the x power. So as you can see, to solve these problems, we take our information about the points, we write out what that means in terms of the function, and then we have to solve usually a system of equations. Usually we have to solve 2 equations and 2 unknowns. However, if you are lucky enough to get one of the points, which has an x coordinate of 0, it does simplify things because that immediately allows you to determine a.